Hi, I'm Oliver Spires. This is Lab 10 on lasers.
And I'm David Lopez.
For our first experiment, we looked at a helium neon laser cavity. We first aligned a commercial laser to the table by using an iris and passing the laser through a near point and a far pinhole, and using tip tilt to align the laser. We then aligned the helium neon laser cavity with its mirrors to the commercial laser by translating and adjusting the height, and then inserted a mirror and aligned that mirror to the reflection out of the tube. The one transparent diagonal face on the laser cavity is a Brewster window, and it allows the horizontal light to be amplified while reflecting the vertically polarized light. We expect it to, assuming an index of 1.5, to have an angle of 56.31. We were able to get the laser to laze, and we had 3 different radial modes that we observed, but we were only able to get one transverse mode that was similar to this one. We did observe using a linear polarizer that the light was horizontally polarized as we expected.
So for this experiment we used a helium neon laser, 2 mirrors and a beam splitter, input into an oscilloscope to measure the mode spacing of the laser input. We used this Fabry-Perot resonator hooked up to the oscilloscope to measure this mode spacing. Okay, using the oscilloscope we measured this spacing, number 1, to be 127 milliseconds and the second spacing to be 6.8 milliseconds. Using that data we were able to calculate a value for the delta nu, which we found to be 535.4 megahertz. From that we were able to estimate the length of the cavity of the laser, and we estimated that to be 28 centimeters. Don't you we used the ESA to measure the beat frequency, which we found to be 562.2 megahertz. The spacings obtained with the ESA and the oscilloscope were within 5% of each other. Here, we measured the cavity length of the laser using a ruler, so we roughly estimated, using that measurement of 32 centimeters, we roughly estimated to be 468 megahertz. This is an overestimation of the spacing of the cavity length that we. Okay, using a linear polarizer, we were able to find the polarization of the laser, which we found to be linearly polarized at 45 degrees. For the third experiment, we used a beam scope to measure the beam diameter at 3 different distances. From there, we found the slope. Using the slope, we found the divergence angle, the numerical aperture, and the waist diameter. This was for a helium neon laser.
For resonant frequencies between plane mirrors, the arc cosine term will be killed by the infinite radii, eliminating dependence on m and n. And these are the answers.